Alrighty, so today we are looking at triangle congruency proofs. Now we've done proofs before recently, but we needed 6 components. So if we're thinking back to what we did before, we needed 6 boxes, and we could have had other boxes leading into some of those boxes, and then all together we could say that triangles were congruent due to CPCT, DPCT, C. And that was fine. But now we know about all of our triangle congruency patterns. We have side, 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 SSS, side, angle, side, SAS, ASA, which is angle, side, angle, and AAS, which is angle, angle, side. So for each of the proofs that we're going to do today, we're only going to need 3 boxes. So when we are proving triangles congruence, you can see here our final box is going to be our prove statement. We're going to only need 3 boxes funneling into this at the very least, right? We can always have other elements happening here. So the first thing that I want to do is just figure out what this picture has going on. What are our givens? So I can see one given right here. I have this here in purple, that AD is congruent to DC. So let's go ahead and fill that in. AD is congruent to CD. That's one of my sides, and I knew it because it was given to me. What else is given to me? Well, this angle right here, angle ADB and angle CDB. So let's fill that in. Angle ADB is congruent to angle CDB, and that was also given to me, and that one is an angle. And now I need to relook at my picture to see, well, what else do I know? So I'm going to change my color since it's no longer given. I don't know anything about these angles. I don't know anything about these angles. I don't know anything about these sides, but I do know that this side is congruent to itself. So I'm going to say that DB is congruent to DB. And that's relevant because it's part of 2 different triangles. And it's not given to us. We know that. That's our symmetric property. And I will give you a list of properties that work as well, but I would also encourage you to look that up. What does it mean for a line segment to be symmetric to itself? And a quick Google search would tell you that that's symmetric. So that is another side. So I don't want you to look at this and say side, angle, side. Well, that must be my proof. It just so happens that in this case it is. So let's remind ourselves on how we find that, and that's just from the picture, all that good work we did together last class. I have an outside angle, and then I have the included angle. Sorry, I did not have an outside angle. I don't know what I'm saying. Miss Humming, what are you doing? I marked those as not. I have a side, I have the included angle, and then I have another side. So that is, in fact, SAS. So my reason is SAS, and my triangle congruency is going to be the exact thing as my prove statement, which was triangle ABD is congruent to triangle CBD. And that's my completed triangle congruence proof. And so now you can see why we do like these patterns so much, because it saves us so much work. Now we only have to have 3 things right here, 1, 2, and 3. And obviously they can be a little bit more in depth than this, but it gets us to our result right away, and we don't need to have all of that other information. Now, of course, the other sides must, now that we know they are congruent, the other side and the other 2 angles are now guaranteed to be congruent, but we only know that after we write this congruency statement. So in fact, what I'm going to do, let's see if I can figure out how to do this, is I am going to take this piece right here, and I am going to, copy that. Maybe I'm not. I thought I knew how to use this. Nope. Okay. We'll just move down to the next one then. And we will do it down there. Oop. Okay. So what we had then here is the same exact thing. The only thing that changed is our prove statement. So exact same problem we had above, except we're going to actually go one step further. We're going to end up drawing an arrow outside of here. So when you set these proofs up, we're going to have those three statements that are going to lead into our triangle congruency statement, which will then lead into our prove. So let's just fill that back in with the information we knew from before. So I'm just going to do a quick zoom in here. This was a side, and it was given to us. We knew that AD was congruent to CD, again, because it was given. We also knew that angle ADB was congruent to angle CDB, because that was given. And then we used our symmetric property, to find a side, which is the one that says that a side can be congruent to itself. And then we wrote out our triangle congruence proof, which was the original one, that ABD is congruent to CBD, and the reason was SAS. And just like before, we said we used this side, this angle, and this side. Now, you needed to do this step in order to prove this. So remember, now that we know that the triangles are congruent, then we know that the other two sides, the other side, and the other two angles are also going to be congruent. And the reason for that, and this is the new part, we can now say that angle A is congruent to angle C, right here and right here, because of that old rule, CPCTC. And if you recall, we had CPCTC and we had the converse of CPCTC, saying if we know all the parts are congruent, then we know the triangles are congruent. But guess what? If we know the triangles are congruent, then we know all the parts are congruent. So for each of the three examples that we are doing together today, we'll first solve that the triangles are congruent, and then we'll move on to prove that an angle or an additional part is also congruent. All right, so let's do a new example just so you can see. So what I'm seeing here is I have a side is congruent to a side, and a second side is congruent to a second side. And then just from all the puzzles we did last class, you can see where we're heading is to then prove that this side is also congruent to itself. So let us draw in our little proof. We start with 3 boxes. And that's going to prove our triangle congruency statement, like so. So what's the first line that we have? PQ and RQ. PQ is congruent to RQ, and they are line segments. And again, that was given to us, and that's a side. Another side that was given to us was SR and SP. Again, that was given, and that's a side. And the one that wasn't given to us, I'll just do it in a slightly different color, is that this line segment is congruent to itself. So we are going to call that, that's our SQ, is congruent to SQ. You could also say QS. And the reason for that, again, is our symmetric property. Symmetric property. So when that all in, and you want to make sure that you copy this statement exactly, we're going to say that triangle PQS is congruent to triangle RQS. And that reason was 3 sides congruent, side, side, side. Now, there's a couple things I want you to check when you're doing these problems. And the first is that you write your statements as exactly so that your proof statement and this statement match, all the letters in the right direction. And then we want to check all of our congruency statements, PQ and RQ. See how PQ and RQ are in the same position in our congruency statement? So that is good. SR goes from the last to the first. And so SP also goes from the last to the first. So those are in the same order, so that is good. And SQ goes back to front, back to front. They're also in the same position. So you just always want to check those positions. If we move to the next slide, and I'm actually just going to come back and rewrite it on this one, but the next proof statement they wanted us to prove here was that angle PQS and angle RQS are the same. So that would be angle PQS and RQS, and we can prove that up here. I'm just going to change our proof. That angle PQS is congruent to angle RQS. So again, that would be here and here. And remember, once we know that our triangle is congruent, we can say that any of the other pieces, in this case it would have been the other three angles, are also congruent, and our reason is just CPCTC. So there's really two types of proofs is what I'm trying to show you, and they will be mixed together. If it's asking you to prove triangle congruency, you're going to end right here, and you're not going to use CPCTC. If it asks you to show that angles or sides are congruent, no, you're going to still have to prove this, but you're going to go one step further using CPCTC to solve that last little bit there. And I also want to make sure that we know that not all proofs are as straightforward as this. They all don't fit that same format. So I'm going to show you how one bit of information, we're going to back draw a little extra box for our proofs. So here's this next one. It wants us to prove that ABD is congruent to CDB. So looking at our picture, we want to say, well, what do we know here? And the only thing we know is an angle and parallel. So those aren't congruent, those are parallel. So we do know that we will need one, two, three boxes, which our three boxes will always lead to our triangle congruency statement, whatever that may be. But we have to figure out how we can get there. So right away, we do know angle A is congruent to angle E. And that's given to us, and that is an angle. But I don't know here what else is going on. But what does parallel tell me? Well, if these two lines are parallel and they're being cut by a transversal, well, then these angles here are congruent because they're alternate interior angles. So we have to say all that. So I don't want to write my parallel statement in here in my box, because my box, it's not an angle and it's not a side. So instead I'm going to draw my parallel statement out here, and I'm going to lead it into my box. So my parallel statement, which was my given, is that AD is parallel to BE, and that was given to me. And what that led to was that those angles were congruent, and those angles was angle ADB is congruent to angle EBD. And that is an angle, but that wasn't given to me. My reason is that alternate interior angles are congruent. So I'll read that again. Alternate interior angles are congruent. There's my little angle symbol. And so I had to backtrack a little bit and add a box. So again, I knew that these were congruent, cut by a transversal, so I happened to pick these two angles, and that's good. Now, I could pick these two angles, but what would be the problem with that is then I would have angle, 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 and angle, angle, angle does not prove congruency. That's not a good pattern. What does work is angle, angle, side. So let's come back to this And we'll look at this side right here. It's a part of both triangles, so it's going to be congruent to itself. So we have BD is congruent, and this time is equal to BD. I'm going to call that reflexive property instead of symmetric property, and I'll explain that to you in a second. So we have a side. So notice how this triangle is going from right to left and then down. Well, this triangle that's similar is going, left to right and then down. This one's going right to left and then up. So really, these have been reversed. So when we read this triangle, BD, and we read this one, DB, they're in different orders. So we need to reflect that in our statement, which is why I used BD and DB instead of BD, BD. And that's just the difference between our reflexive property and our symmetric property. So here, I'll give you guys this if you want to write this down for your notes. This is symmetric. Let's call this AB. When AB is congruent to AB. But if it's like reversed, here's A, here's B, it's reflexive when we have AB congruent to BA. So see the difference in those pictures? How one, they're both going in the same direction. It's like a mirror image, and the other one's more of a reflection, a rotation. Those R words are going to give you reflexive. Okay, back up to our proof. We just have to finish writing in our proof statement, which was ABD and CDB. ABD, CDB. This should be BD. Just make sure you copy it nice. ABD and CBD. And again, the reason for that, let's look at our reason, because it doesn't just follow that it's going to be AAS necessarily. We need to look at what is happening with our picture. What do we have? We have two angles and a side. Our angle is here, here, and our side. Here, here, and our side. So it's not, the side is not the included side, it's on the exterior side. So that is AAS. And I just want you to be extra careful there, because say I wrote the proof this way this time, next time maybe I had done the different alternate interior angle, and it could have a little bit of variation in the way that that looks. So that is our finished proof. Just like with the other two, we want to say, well, what if we had a different proof statement? The next problem was going to be that AB is congruent to DE. So let's write a new proof statement. We're going to prove that AB is congruent to DE. That is this right here, AB, DE. So let's put like some dashes through that to show that they're congruent. And we know they are congruent through that one last step that's always the same. AB is congruent to DE, and you guessed it, CPCTC. So that's that extra looking step in there. So when it comes to triangle proofs, practice really makes perfect. You're going to need a lot of support and a lot of materials the first couple times you go through them, but you'll start to recognize patterns and things to look for. Some things to look for. Let's look for some spaces. I showed you the two before. You always want to look for connected sides. These sides are always going to be congruent to themselves, either using the reflective or the symmetric property. You also want to look for this. Remember, vertical angles. That's something that always pops up. And this case is something that pops up too, where we have parallel lines, and then we're going to be able to use alternate interior angles. So the proof packets that you'll be working on this class and the next, you will see that they give you the list of our normal list, like side, 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 angle, angle, and AAS. But it's going to give you some common properties, definitions, and theorems as well. We talked about reflexive, symmetric. What about definition of a midpoint? So if it says something like, here is your triangle, and you have this line segment, it tells you this line segment's a midpoint, well, then you'll know that those two are congruent. We talked about angle, vertical angles. You have angle bisectors. We know that right angles are congruent, and we also have the third angle theorem and other ideas with bisectors. So it'll definitely be a lot of practice, but we will get through it, and I'm here, and so is this video if you need more help.